electricity. All of you, please give the heading as current electricity. All of you, please give the heading as current electricity. Okay. So, I'll give time for writing. You will listen to my story first. And when I say you to write, you can write it. Please understand what you're going to learn in today's class. Not in today's class, how it's going to go in the entire chapter. What are things we're going to learn. So, I said you in the beginning of the 12th standard that a student, if he wants to be good in the whole physics of 12th, they must be good in 1, 2, 3, 4, 9. I'm talking from CBSE book point of view. That is, you should be good in electric charges and field. You should be good in electrostatic potential and capacitance. You should be good in current electricity. You must be good in moving charge and magnetism, and then ray optics. Because these 4 chapters are the most complex part of this whole syllabus. And believe me, if you have command on this 4 chapter, if you feel these 4 chapters are simple for me, then you are done. Automatically you will do good in the remaining chapters also. So please mark my words, and if you are serious about the board examination, from now itself you should remember 1, 2, 3, 4, 9 is the most important part of physics. In that, 1 and 2 we have covered very slowly in the last 2 months, not went very fast. Some schools are on the verge of finishing 3rd chapter itself. Started 4th chapter also in some schools. But I am going quite slow, where I am making you to understand each topic break by part by part. I will follow the same rule. So my target is before we close for summer vacation, close in the sense the regular class closing, that time I should finish 4 chapters. That is my target in my mind. 1, 2, 3, 4 I should finish. In that context, I am starting 3rd chapter. 3rd chapter is not as long as 1 and 2. So it is small compared to 1 and 2. In this chapter, you are going to continue learning what you learnt in 10th standard. So I believe that something from 10th standard you retain in you. If you say nothing, sir, I forward everything, then it will be a little difficult for you. But I'll try to recall everything in today's class, where what is the meaning of potential difference? What is the Ohm's law? What is the resistors in series? It is in parallel. How they behave? Heat energy stored by the current. All these things you have learned in the 10th standard. And today we are going to learn the detailed part of those things. Okay? Shall I start the class today then? Okay, fine. So we have given the heading as current electricity. So I would definitely like to ask you, what is the meaning of the word current? What is the meaning of the word current? Flow of charges. Don't you have water current? Water current also is flow of charges. Current means to flow here, does not mean to include charge there. Current electricity, if I ask, what you are saying is correct, flow of charges. But if I ask you what is the meaning of the word current, current is just flow. Electric current or current electricity is only the flow of charges. So one thing is very sure, here charges are going to move. Chapter 1, chapter 2 were electrostatics. Our charge was at rest. I said in the first class to you, charge at rest is capable of producing only electric field around it and electric potential also, obviously. When the charge starts to move, it becomes current. In this chapter, we are going to study about electrodynamics, which is movement of charge and what things it produces. Charge is moving, it makes current, and the current will make magnetic field around it. Like in 10th standard, you studied current and magnetic effects of electric current. In this class, you will study about current and moving charge and magnetism in the 4th chapter. Interesting 2 chapters. So today's class, we will learn about how a conductor is conducting current. We will learn about one very good concept where you will realize that conductors, even though they have free charge particles, why they don't have current? Like for example, if I see this panel, it is made up of aluminum. So this aluminum is a metal. Do you agree with me? Yes. This is made up of steel, metal. Metal has free charge particles. Do you agree with me? Free charge particles are there. Then free charge particles are at rest or motion. Rest. Particles can never be at rest. Kinetic theory of gases 11th standard. The particles, little bit of temperature also. Don't think temperature is required in 100 degrees Celsius. Even if it is minus 20 degrees Celsius, it will be in motion only, because energy is equal to 3 by 2 kT from 11th standard. Remember that whenever you have a temperature, we have motion. Yes. That E is equal to 3 by 2 kT is applicable to any molecule. Wherever you have a particle, if it is having a temperature T, it will have energy 3 by 2 kT. Solid, liquid, gas, anywhere. So the temperature increases, the velocity will increase further. But does not mean that it is at rest. It can be at rest. You know what temperature? 0 Kelvin. Absolute zero temperature. So if you want a particular element to have no motion of the charged particles, it is possible. What temperature? 0 Kelvin means minus 273.15 degrees Celsius. We cannot even create it in the room. We have to create it only in the laboratory, controlled environment. Are you getting my point? So it means that any conductor, any metal is having free charged particles which are in motion. Now, if the charged particles are in motion, just now I told, charged particle starts to move, it produces current, flow of charges. So if it is producing current, when I am touching, why I am not feeling the current? Minute current. Oh ho. Is it like that? It is going in? Good. It is going in random direction. Very good. So these charged particles, since they are not moving in a particular direction and they are just moving in random directions, they are not able to create a net effect of current. So current is zero. But somehow if these charges would have come in the same direction and moved together, then it will produce current and you will feel it. You know who will do that work? Battery or the potential. Not only battery, even this socket is a source of potential only. So many of you think from your childhood, this will give current. Many of us think like that, common sense. Current point. We'll say like that only, no? That point will have current. Because we are speaking like that in language. But never think that point is giving current. Point is just giving potential difference. And that potential difference is creating the flow of charges in a particular direction. And that makes current. So where are the charges present already? It is present in the metal itself. If wire is there, wire has charged particles. Some of you are thinking that, okay, in the socket, charge is coming from outside. We are buying charge from the market. You may think like that. Battery, we are buying, charge is there. When you put a battery inside a remote, charge starts to move from the battery. No. Battery is not giving charge to you. Battery is just giving potential difference, which makes the electron present in the wires to move in a particular direction, which will produce current. Very basic thing. So today's class, we are going to learn about all these topics in detail. We are going to learn about Ohm's law in vector form today. When I say Ohm's law, immediately you will get V is equal to IR. I think everybody will get V is equal to IR. But today you will learn Ohm's law can be represented in vector form also. And what is the vector form? Let us learn today. Okay. If time permits, we will also learn about temperature dependence of resistance and resistivity. This is my today's agenda. Okay. We will start one by one learning all the concepts. Fine. Clear? So first you give the heading of this today's classes, drift velocity and relaxation time. The heading is drift velocity and relaxation time. Please be attentive. I will give time for writing. Okay. So as I said before some time, I am having a conductor. Let me assume the conductor is of some length L. Okay, there is a conductor of some length L. In this conductor, what do I have? I have free charge particles, but how they are moving? They are moving in random directions. So every charged particle has a velocity. but this velocity is not in a particular direction. So I can say that the net velocity u net, initial velocity u net, will become equal to u1 plus u2 plus u3 plus u4 up to un by n. This is the overall velocity of what? Of all the electrons, and this value is equal to 0. Why is it 0? Because it is not in a particular direction. It is randomly oriented in all the direction. I'll give time for writing. Pay attention, learn. So the net effect of all these velocities is equal to 0. The moment you are connecting this conductor with an external source of EMF, electromotive force, what happens? These charged particles starts aligning themselves in the direction of electric field. If it is positive charge, in the same direction of electric field, negative charge against the direction of electric field. Do you agree with me? So if I am having an electric field coming in this direction, the charge will get drifted towards this direction. Are you understanding this? So to talk about this drift velocity, I must realize that the moment I am applying electric field, in this direction I applied the electric field, the force starts to act on a charged particle. In the previous chapter you have learned electric field is equal to F by Q. So F is equal to Q into E. Did you see it in the previous chapters? It means whenever a charged particle is placed inside the electric field, it experiences a force. If it is a positive charge, it experiences a force in the same direction of electric field. If it is a negative charge, it experiences a force in the opposite direction to electric field. Are you getting my point? So here, what is the force this electric charges are experiencing? They are experiencing a force of negative Q into E. Since it is an electron, I am writing just E into E. Why did I put negative sign? You are realizing negative sign is indicating that force and electric field are in opposite direction. And you know very well F is equal to ma. So ma is equal to minus E into E. From here I get the acceleration of the electrons. You know why I need acceleration? Because if you want to find the final velocity as per the law of mechanics, V is equal to U plus AT. For that reason I am finding the acceleration. So acceleration of each electron is given by minus E by M. Do you agree with me? In school exam, in competitive exam, question can come directly from here. Acceleration of a charged particle when it is placed in the electric field. How much is that? Minus E by M. Where small e is basic elementary charge, capital E is electric field, M is the mass of the electron. 9.1 into 10 to the power minus 31 kg. Understanding what I'm trying to say? So acceleration of the electrons when they are subjected to the electric field is given by minus E by M. Now I got the acceleration. I have the initial velocity. I can find the final velocity. Can I? So let me try to find the final velocity. So final velocity will be, that is, if I take electron by electron, V1 will become equal to U1 plus A into T. How much time it takes? I'm taking it as T1. Now, what is the meaning of T1? Let us try to realize, understand that. What happens when it is accelerated? The moment the charge is accelerated, it will go and start moving in one direction. But is it alone? It is with so many charges. If it is having so many charges around it, it will definitely go and hit some other charge, isn't it? It is not human beings that I will walk and go in a line where I will not touch people, right? There are millions of electrons and it will definitely go and hit the other electron. That time, how much it takes to go and hit the other electron is taken as T here. That is, it is known as relaxation time. The relaxation time means average time between successive collision of an electron. Are you realizing this? U is the initial velocity, A is the acceleration, T is the relaxation time. It means average time between successive collision of electron. Now, do you think that all the electrons in this conductor will have the same time of relaxation time? No. Somebody may go and hit in less time because more space was there for him. Some electron may go and hit in very late because it will have more space. Something will hit immediately, it has less space. T1 will not be same. T1, T2, T3 like that. Different electrons will have different equation, like V2 is equal to U2 plus AT2. Like that, I can make Vn is equal to Un plus ATn. So I got the values of V1, V2, V3, V4, V5 up to Vn. If I find the average of all these velocities, that is known as drift velocity. It means drift velocity is average of all the velocities with which the electron is drifted when it is subjected to an external electric field. Now, to mug up all this definition, understand what is happening. The moment you applied the external electric field, electrons got drifted. The average of all the velocities with which the electrons are getting drifted against the direction of electric field is known as drift velocity. So, what will be drift velocity as per the equation? Vd will become equal to V1 plus V2 up to Vn by n. So, I am taking average of all the V. Put from the equation, Vd will become equal to, what is V1? U1 plus A into T1. Same way U2 plus A T2. Like that, Un plus A Tn divided by n. If I take all the U1, U2 together, U1 plus U2 up to Un by n plus A into T1 plus T2 up to Tn by n. Can I write like this? Yes, I can write like this. I'm just breaking these terms AT1, AT2, ATN separately and U1, U2 separately. Why? Because I know the value of U1 plus U2 plus U3 plus U4 up to Un by n is 0. I did know in the previous slide. You remember? This value is 0. So I can write drift velocity is equal to A. What is A? A we got minus EE by M. So I can write minus E by M, and all the average of this relaxation time is called as tau, which is called as average relaxation time. So if they ask you define drift velocity, you will define drift velocity as the average of all velocities with which the electrons are drifted against the direction of electric field. If they ask you define average relaxation time, you will define it as it is the average time between successive collision of electrons. So we get the relationship of drift velocity with respect to average relaxation time as minus E tau by M. Very important for the examinations, where E is the basic elementary charge, capital E is the applied electric field, tau is average relaxation time, and M is mass of the electron. If it is clear to you, don't take much time. Please copy these notes fast. If it is clear to you, please copy these notes. Don't take much time. Devadarshan, your video is off. Every class you are doing this year. I'll make you to come for the offline class then. If you are hearing me, Devadarshan. Yes. Can you define tau? I will define both now. VD also and tau also. First you write this. I will define both. Okay, sir. Shall I go to the next page? Shall I? Make it fast. Make it fast. Make it fast. I'm going to next. Yeah. So tell me, Pratap. U is the initial velocity of the electrons. Yeah. I'll go to the next page now, please. Let me know when you are done. Yes. So if you have written, you can define drift velocity now. I'll tell you those who want to write. If you want to write for the exam sake, you can write the definition of drift velocity. Shall I say? Please write it down. If you're writing something else, leave some space. It is the average of all the velocities. It is the average of all the velocities. It is the average of all the velocities with which the electrons are drifted. With which the electrons are drifted. With which the electrons are drifted against the direction of electric field, against the direction of electric field, that's all. Next you write average relaxation time. The definition of that: average relaxation time. And you write, it is the average time, average relaxation time, tau. It is the average time between the successive collision of the electrons. It is the average time between the successive collision of the electrons. Between the successive collision of the electron. Shall we proceed now? Okay. So not over yet, just the beginning of this topic. So now we have come to know that if you have a conductor whose length is L, and if this conductor is subjected to an external potential, then it will make the electrons to get drifted and the current starts to flow. I hope everybody understands this now. So for current to come, potential is must. Without potential, you cannot have current itself. Okay. The length of the conductor is assumed to be L, isn't it? Please don't write anything now. I am going to explain you something, then I will give the heading for the topic. I am not even giving the heading now. Please pay attention now. So, we know very well that current I is equal to Q by T. Anybody has doubt in this? Studied from your 10th standard itself, isn't it? Charge per unit time is current. Okay. So now, you also studied in quantization in the first chapter, Q is equal to NE. Everybody remembers this? NE by T. N is the number of electrons present here and E is the basic elementary charge. I am using the word capital N. There is a reason for that. So I am taking capital N as what? Total number of electrons. If you take total number of electrons and multiply by basic elementary charge, which is 1.6 in 10 power minus 19, you get total charge. And divide that charge by time, you get the current. What time? Time taken for the electron to cross this conductor. Am I right? What is T? Remember, this is time taken by an electron to cross the conductor. To cross the conductor means to go across the conductor. To go across the conductor. So we can find that time easily because we know velocity is equal to displacement by time. Time will become equal to displacement by velocity. So can I say that this time will become equal to length by Vd? Do you agree with me? Velocity with which it is getting drifted is Vd. Length is L. How much time it will take to get drifted fully will be length divided by Vd. Also, here I am assuming the charge density, electron density as N, which is equal to number of electrons per unit volume. Please understand this. Electron density means how much electron is there in this volume. See, in this case, I took some area of cross section and some L. But for different cases, it will be different. So I am finding for a unit volume how much is the electron density, and then I can use it for any relation. So electron density is number of electrons per unit volume. So from here you get number of electrons is equal to electron density into V. Now what is electron density? How much electrons are there in unit volume, and what is V? Total volume. So what is volume? Area into length. I hope everybody knows cylinder. If you multiply the area of cross section into length, you get the volume. So what I can write from here now, I is equal to, this is equation number 1 if you want to write, this is equation number 2 if you want to write. From 1 and 2 I can write, I is equal to, N is how much? Small n into V. What is V? A into L into E divided by T. What is T? L divided by Vd. Do you agree with me? How I have written this? From 1 and 2. L gets cancelled. You get current is equal to N E A V D. I can assure you the question will definitely come in board exam from here. It will definitely come in NEET exam from here. It may come in engineering exam from here. Are you getting my point? So this relation, the heading is, now give the heading, relationship between current and drift velocity. Relationship between current and drift velocity. Relationship between current and drift velocity. And then you can write whatever I've done on the board. The relationship is I is equal to NEAVD. I is equal to NEAVD. Make it fast, don't take much time. Done? Can I proceed? Shall I? Make it fast, please. Okay. Now everybody please pay attention. See how it further proceeds. I have got I is equal to NEAVD. I have got I is equal to NEAVD. What you must be careful is, what are these NEA and VD? N is not number of electrons. Number of electrons per unit volume. What is E? Basic elementary charge. What is A? Area of cross section. What is VD? Drift velocity. Okay. Many will forget N is not number of electrons, it is number of electrons per unit volume. So please be very careful about that. Coming back. So I will become equal to N E A. We just now found the formula of VD. Its magnitude is how much? E tau by M. I can put my negative also, but negative just indicates that the drift velocity is in the opposite direction of electric field, nothing else. So I'm just writing its magnitude. E tau by M. E tau by M. Now please pay attention. I'll give time for writing, please. In the previous chapter that I told you, you learned something like electric field is equal to electric potential by distance. You remember this? I have told this will be used in many places. Remember this value through the last chapter. Till the last chapter it will be useful. E is equal to minus dV by dt. That is, electric field is electric potential by distance. So here I can write I will become equal to N E A. I'll put square here. Instead of E, I am writing V by L. And M is already there and tau is there. Can I write like this? So what I have used here? Since electric field is equal to electric potential by distance. So I have replaced E with V by L. Now I is there and V is here. Can I write V by I from here? V by I. So V by I will become equal to M L by N E square tau A. What is V by I called as? R. Resistance. V by I is equal to R. V is equal to IR. So I come to know resistance is equal to M L by N E square tau A. You know one thing, up to now you are thinking that R is a constant. V is proportional to I. So V is equal to IR. In 10th you studied V is proportional to I. That is what Ohm's law is. Ohm's law says that potential difference across a conductor is directly proportional to the current flowing through it under constant temperature. V proportional to I, so V is equal to R into I. But now you have got the formula of R. So now one more thing we are understanding. From this derivation you realize that R is proportional to L. R is inversely proportional to area. In 10th you studied factors on which resistance depends and you told R is proportional to L. R is inversely proportional to area. How? Because of this. Resistance is proportional to length. Resistance is inversely proportional to area of cross section. You also learned in 10th standard, resistance depends upon temperature. Four factors are there. First was length, area, nature of material and temperature. Now when you change the temperature, suppose you increase the temperature, electrons will become more energetic. They will go and hit other electron more sooner. Tau will reduce. Temperature is increased, tau will reduce. Tau will reduce, R will increase. That is why increase in temperature leads to increase in resistance. You know why? Because the temperature is increasing, tau is reducing. Why tau is reducing? More energy, more fast, go and hit. Tau will reduce. Tau will reduce, R will increase. Third point also clear. Fourth point is the nature of material. Nature of material is given by this N. That is number of electrons per unit volume. Now number of electrons per unit volume is what? It is a function of what it is made up of. Aluminium will have different electron density. Gold will have different. Copper will have different. That's why we say that resistance depends upon nature of material. So see, length, area of cross section, temperature, nature of material. So in 10th, what you studied, this is the reason for that. Are you getting? So if you ask you, what are the factors on which resistance depends? The answer will be, it depends upon length, area of cross section, temperature, nature of material. I hope you understood all these things. And since this M, this L by A is there, no? So from here I can write rho is equal to M by N E square tau. So because resistivity is independent of length and area of cross section. If it is not visible to the people who are in online, this color I have chosen is, I think, a wrong color. I'll write it with some other yellow. That is rho is equal to M by N E square tau. This is the formula of resistivity. This is the formula of resistance. Remember this. Copy it up fast. we have found what is the formula of resistance and resistivity. Resistance is ml by ne square tau A and resistivity is m by ne square tau. This Friday I will be coming for the class. Please don't miss the class for any reason. Okay? This Friday it will be physics class. So please be present. Yes. I said that resistivity is independent of length and area of cross section. Am I right, Pratap? So I just removed length and area of cross section. I got the term as m by ne square tau. So I wrote that constant is resistivity, which is n by ne square tau. Okay? And you should also know that there is something called as G. You know what is G? Conductance. It is called as conductance, which is actually reciprocal of resistance. And there is something called as sigma, conductivity, which is the opposite of what? Resistivity. Remember, this sigma is conductivity, which is reciprocal of resistivity, and G is conductance, which is reciprocal of resistance. Yeah. The SI representation is sigma. If you want to use kappa, you can use, no problem in that. Okay? But sigma is the representation of conductivity. Sigma is 1 by rho. So what will be its unit? Resistance unit is what? Ohms. Resistivity unit is ohm meter. So it will become ohm inverse. And this will become ohm inverse meter inverse. What is ohm inverse known as? Siemens. Siemen. Siemens. So this will become S. So either you can write ohm inverse. Ohm inverse is also called as S. And it will become Simon meter inverse, isn't it? Because ohm inverse will become Siemens and this will be meter inverse. So it will become S m power minus 1. So these are the units. Sometimes the question comes from unit also. So we should be careful about unit of conductance and conductivity. Is it clear? Up to here, whether things are clear? If yes, then give the heading as. Shall I go to the next page?
1 minute.
Make it fast. Leah Varshini, you let me know when I can go to the next page, okay?
Yes, sir. Thank you, sir.
Okay. So now let us try to understand what is the meaning of the word current density. Before I talk about current density, you should answer one question now. Very simple question. Current has a magnitude, isn't it? Yes, amperes. Q by T is coulomb per second, called as amperes. Current has a direction. Obviously, yes, from positive to negative it flows. So current is scalar or vector? Current has magnitude. Current has direction. But whether it is a vector quantity? Huh? It's scalar. What is tensor quantity? Mr. Sharan Ram, what is tensor quantities? Current can be, we'll talk about tensors later. Current can be considered as scalar because even though it has magnitude and direction, it does not obey vector laws of operations. That is for layman's understanding. Why I am saying layman's? Because you studied about vectors in the 11th standard, then they would have told you there. But now, if it is a vector quantity, we have to prove it. We will prove now with the help of current density. So current density is represented by the letter J. Obviously, vector quantity. Current density is J vector. Now, what is the meaning of current density? Please pay attention. This concept is going to be used in two more chapters. Not current density, but what I'm going to teach now, the concept. The same concept will be used in EMI. It will be also used in, already it is used in electrostatics also. I talked about electric flux, you remember? Electric flux, I told you, it is the number of electric field lines passing normally through an area, isn't it? Same way, current density is defined as if the electrons are moving, it is going to produce current. So it is defined as how much current flows per unit area. Which area? The normal area. So current density is defined as current by A normal. Now, what is the meaning of A normal? Please pay attention. Suppose you have a surface like this. This will be the area vector of it. You know what is the meaning of area vector? Perpendicular drawn on an area. If this is the area, this is area vector. If this is the area, this is the area vector. If that is the area, this is the area vector. So what area you are taking, accordingly you will get the area vector. Okay? So this is the surface, this is the area vector. Now, if this is the area vector and this is the way the current is, charge is moving, so the angle made between current, that is the charge movement, and the area is theta, then the normal area will be how much? A cos theta. And this side you will have A sin theta. A sin theta is of no consideration because we are going to bother only about the A cos theta. Same thing we did in the case of flux also. So can I write that J is equal to I by A cos theta? Now what is A? A is the area vector here. Area vector is the area drawn perpendicular on a particular area. So from here you come to know that current is the dot product of what and what? Current density and area vector. That's why current is a scalar quantity. Since current is dot product of current density and area vector, current is termed, it's classified under the category of scalar and not vectors. It is very true that current has magnitude, current has direction, and it does not obey vector laws of addition. That is also a reason why it is called as vectors, the scalars. But that is not the concept. Concept says that current is dot product of current density and area vector. Please write this up fast. Shall I? Shall I proceed further? Okay. Now you can write Ohm's law, the famous Ohm's law. And most of you will be aware about what is Ohm's law. What is Ohm's law? I need not even teach itself. V is proportional to I. V is equal to IR. Very basic. Very, very basic. And the conductors or the materials that follow the Ohm's law will have a proportionality curve. That is, the line will be a straight line between V and I, isn't it? That is between the potential and the current. Where V and where I? XV or XI? XV, XI. So this line is a straight line. But do you think that all the materials that we are using is having Ohm's law? They are following Ohm's law? Most of material that we are using actually don't follow the Ohm's law. Today we have all semiconductors around us. Everything is semiconductor. Everything is chips only. Go inside the system, semiconductors. Go inside TV, semiconductor. Go inside camera, semiconductor. All the semiconductors, none of them follow Ohm's law. You know this. Because if you draw the VI graph of the semiconductor, it will come like this. Do you think it is following Ohm's law? No. If you take compound semiconductor like gallium arsenic, that kind of semiconductors, that kind of materials, it will have the graph like this, VI graph. Following Ohm's law? No. This is the biggest limitation of Ohm's law. Ohm's law is not followed by many of the materials itself, like conductors don't follow Ohm's law. We have non-ohmic conductors also. There are conductors which are conducting electricity, but they don't follow Ohm's law because the V and I will not be proportional to each other. Are you getting my point? So don't think that everything in the world follows Ohm's law. No. If they follow Ohm's law, then V will be proportional to I. That's it. And one thing I'll tell you, if they are following Ohm's law, then this slope, this tan theta, will be called as the resistance of the conductor. So if you have three graphs, graph A, graph B, graph C, which graph is having maximum resistance? A, B or C? I changed the current, no? Current is here, right? The answer will be C only, no? Sorry, A only, no? It will be A. Obviously C, yeah. That's what he said also, Sharan Ram, in the beginning. Because you must see the theta from current axis, not x-axis. Here I have changed current axis itself. Theta 1, theta 2, theta 3, which has maximum theta? C. Which will be having maximum resistance? C. Are you getting? This kind of question comes in the exam also. There are 3 graphs. Which is the which material is having maximum resistance? Very basic thing I am talking to you. Now let us try to understand Ohm's law in vector form. Very important for the examination. Shall I go to Ohm's law in vector form? Shall I? So you write Ohm's law in vector form. Now this is something which is new for you. Ohm's law in vector form. I'll give time for writing. Please pay attention. Ohm's law, what is that? V is equal to IR. Now please pay attention. I'll give time for writing. Please, please, please. We know that V will become equal to I into R. What is R? Rho into L by A. Do you agree with me? Just now you know R is equal to rho L by A. And what is this I by A? J. So I can write V is equal to J into rho into L. Do you agree? V can be written as E into L. See, potential is scalar. But I know that electric field is equal to electric potential by distance. So I can write V as EL, which is equal to J into rho into L. L gets cancelled. So I will get E vector is equal to J vector into rho. This is called as Ohm's law in vector form. Some books can also write E vector is equal to J vector, and I'll bring the rho here. So 1 by rho will become what? Sigma, conductivity. So I can write J vector is equal to sigma into E vector. This can also be called as Ohm's law. Both are same only, because 1 by rho is sigma. So either write E vector is equal to J vector into rho, or write J vector is equal to sigma into E vector. They both are having same meaning. And this is how we represent Ohm's law in vector form. So Ohm's law in scalar form is V is equal to IR. Ohm's law in vector form is E is equal to J rho, or J is equal to sigma E, however you want to write. Copy it fast. Can I proceed further? Can I proceed further?
Yes, sir.
Yes. Next topic is temperature dependence of resistance and resistivity. Temperature dependence of resistivity. So we know very well, we have learned in before few minutes, that if you increase the temperature, the resistance or resistivity will increase. Why it increases? Because tau is reducing. Why tau is reducing? Because they get more energy, they get more velocity. We understood this. But how much will be the increase, we have not learned. We came to know that if you have a conductor, you pass temperature to it, it will become more resistant, or it will have more resistivity. But if the conductor is at 60 degrees Celsius, and you make it to go at 90 degrees Celsius. How much the resistance has increased? We don't know about that. Resistance having a resistance of 3000 ohms. You heat it by 60 degree. What is the temperature? What is the resistance now? You cannot say the answer. Because we don't have a formula which relates temperature with resistivity. We are going to learn about that now. So there is a formula which relates. Derivation is not there in syllabus. It is not there in context from long time. The formula says that resistivity at temperature T is equal to rho naught into 1 plus alpha T minus T naught. This is the formula that relates resistivity with temperature. Now please pay attention. Pay attention, please. What are the meaning of all these things? This rho T, it means resistivity at a particular temperature. Rho naught is what? Don't take initial, that's the problem. Oh, resistivity at not absolute zero, room temperature. At room temperature, which is taken generally as 27 degrees Celsius or 300 kelvins, not 0 Kelvin, man. Alpha is what? Alpha, beta, gamma. Expansion event, thermal expansion event. Alpha, what we are saying is linear expansion, isn't it? This is called as thermal coefficient of resistivity. Thermal coefficient of resistivity. And T is the temperature at which you are finding the resistivity, and T naught is what? Room temperature. Very simple. From here, if you want to find alpha formula, you can find alpha formula. What will be that? Rho T divided by rho naught is equal to 1 plus alpha delta T. T minus T naught is delta T. So I can write alpha into delta T becomes equal to rho T by rho naught minus 1. So what is rho T by rho naught minus 1? It will become rho T minus rho naught by rho naught. This side what you have? Alpha into delta T. What is rho T minus rho naught? Del rho. So I can write alpha into del T is equal to del rho by rho naught. So alpha will become equal to 1 by rho naught into del rho by del T. This also can be written. It's not something very big thing. From here I just rearrange the terms, nothing else. What I did is rearranging of terms only, no here. Change in temperature I took it as delta T. Change in resistivity I took it as delta rho. That's all. I hope you have understood this. So nothing big we have done. We have found the value of alpha in terms of rho. Same way, if somebody wants to write resistance, they can write RT is equal to R naught into 1 plus alpha T minus T naught also. No problem in that. Because rho is equal to R into A by L. So AL will get cancelled. RT will become equal to R naught into 1 plus alpha T minus T naught. Once again, if you find, you will get alpha is equal to 1 by R naught del R by del T. In differential, in competitive exam, you will get like this. Alpha is equal to 1 by rho naught d by dt temperature of rho. That way also you can write. I hope it is clear. Interesting thing is, from this topic, we have so many questions in the book itself, NCERT book. Copy it fast, then I will open the NCERT book. Shall I proceed? Have you copied? Too much of theory, teaching became a little boring. Shall we go to some numericals? Shall we start some numericals?
Yes, sir.
Can I change the... Or not? Yeah. I don't like this. Yeah. So if you see, we have learned this. Mobility we not talk actually. Yeah. One thing I want to point it out here, please, please, please pay attention. Because this question comes in the examination. I have seen questions coming in even competitive exams from here. They will give a graph and they will ask you to identify which material is this. Or they will ask you the material, they'll give the material to you and they will draw 4 graphs and they'll ask which has the proper graph, which is the proper graph. So remember that this is the behavior of resistivity with temperature for conductors, for metals. This is the behavior of resistivity with temperature for alloys, and this is for semiconductor. So it is very important graph in the book given. This is the graph of rho versus T for semiconductor, rho versus T for alloys, rho versus T for conductors. Please draw it down in notebook now itself. You'll forget it otherwise. Just draw the graph, not the values. Just draw the line, and remember, write down below for conductors. This is for alloys, and this is for semiconductors. What I have done is, what I'm showing to you is the graph between resistivity and temperature, variation of resistivity with temperature for different materials, conductors, semiconductors and alloys. Conductor, semiconductor, alloy. Don't forget to mention on the x-axis temperature, y-axis resistivity rho. I hope you have copied. Can we come to exercise questions now? Conductors, alloys, semiconductors. Can I go to the questions now? Shall I? Yes. Question number 3.3. Those who are having book can use their books. Those who are not having books can use this screen also. 3.3. Fast. Simple question only. I hope all of you are able to see the screen. Question number 3.3. Anshul, you want to say something?
I got the answer 1027 degrees.
Check in the NCRT book. You have the book near you?
No, sir.
1027. It may be right.
Yes, sir.
It may be right. Those who have the book, can you please check in the book back? Last, what is the answer? 27. Yeah, it is correct. Good. Anshul and Niranjan, you also got the same answer. It's correct. Good. I think everybody has seen the question. No, you're writing the question, man. Just write the given data from the question. Why are you wasting time?
Sir, I have a small doubt.
Please ask me.
I'm getting the answer as 1000 from
1000?
1000 sir. I'm getting and 27.
1027. Am I right?
1020. Yes, sir.
Yeah, it is correct.
And my doubt is that can we take the temperature to be in Kelvin?
See, if you take in Kelvin or Celsius, since we are subtracting it, it will have the same answer. No, they have same number of divisions, isn't it?
Yes, sir. Yes, yes.
So there is no problem.
Okay, sir.
Yes.
Okay.
Now those who have got the answer, go directly to 3.4, 3.5. Fast. 3.4, 3.5. Don't take much time. If you have not got 3.3, I will solve it for you. No problem in that. But those who have got the answer for 3.3 can go to 3.4 and 3.5. If you are not getting the answer, don't worry, I will solve it for you. As of now, you can go to 3.4 and 3.5. You have to update your name and phone number in this. 2 into? If you have got, go to 3.5. Even 3.6 is from what we are learning only. Give the save button above. Save is there, no? Save. Above. Done. Yeah. Give to him. Click on add. Something is there, no? Add manually. Write the name and phone number. जब भी क्लास चलता है सारा पर्दा हटा दो, उससे क्या होगा कि एसी बढ़ेगा। समझ में आया क्या हो रहा है? एसी जो है ना पूरा एब्जॉर्ब कर ले रहा है पर्दा, इसीलिए ठंडा नहीं हो पाता है। जब शूटिंग होगा, रिकॉर्डिंग होगा, उस टाइम लगा देंगे हम लोग। क्लास में उतना ज़रूरत नहीं हम लोग को साउंड प्रूफिंग का। ये पूरा इसी की तरह है ना, सब एब्जॉर्ब कर रहा है ठंडा। हाँ एग्जैक्टली प्रॉब्लम हो रहा है, समझ रहा हूँ। तो पूरा का पूरा पर्दा जो है क्लास टाइम में हटा दिया करो। उससे क्या होगा कि रूम तो थोड़ा ठंडा होगा एटलीस्ट। जब तक एक और एसी लगवाते हैं तब तक करना है, ठीक है। कर दो, अनम्यूट कर दो। I think you are added. Kartika Balan is added. Litish not added. Name? Which one? 3.6 is? Do yeah, why not? You can do no. What is the question we can solve means you can solve. 3.345 we have done. We'll discuss all the answers now. I will do on the board. Shall I solve it for you people? Okay. So I'll start with 3.3. So how to solve 3.3 we'll see first, then we'll go to 3.45 and all. So yes. 3.3 question says that at room temperature the resistance of heating element is 100 ohm. What is the temperature of resistance of the element if the resistance is found to be 117 ohm? Alpha is given to you. So what they are asking you to find? Temperature they are asking you to find. T is what you want to find. The formula is rho, they are asking in terms of resistance. So RT is equal to R naught into 1 plus alpha T minus T naught. Then put all the values. RT is how much? 117. Am I right? What is R naught? 100. What is alpha? 1.7 into 10 to the power minus 4 into T. T is how much? 27 you take, or Kelvin, whatever you're comfortable with. If you want to solve in terms of Kelvin, take 300. Completely your wish. So 117 and 100. So what is going to happen? It will become 117 divided by 100, which is 1.17. So 1.17 is equal to 1 plus 1.7 into 10 to the power minus 4 into 27 minus T naught. Am I right? Yeah, obviously correct. Then it will become 1.17 minus 1 if 1 goes that side. If 1 goes this side, it will become 1.17 minus 1, it will become 0.17 is equal to 1.7 into 10 to the power minus 4 into 27 minus T naught. Do you agree with me? Now, this goes down, you will get 0.17 divided by 1.7 times 10 to the power minus 4, which will become equal to 27 minus T naught. Now solve this. 0.17, how much times it will go? 10 times, and this will become 10 to the power minus 3, goes over, it will become 10 to the power plus 3. So you will get 10 to the power 3, which is 1000, is equal to 27 minus T naught. So T naught will become equal to, T naught should come in? Okay, okay. I have taken as 27 minus T naught. Okay, okay. Fine, fine. Yes, I have taken ulta here. It will be T minus 27, isn't it? Then it will become correct. So you will get here T minus 27. So T will become equal to how much? 1027 degrees Celsius. Got it? Very basic calculation. I'd say I think it is not like something we should worry about. No differential integration here. Clear? Anybody has doubt in what I've done? Same way, same logic if you use, you can solve the next question. Can I erase the board? Can I go to the next question? So 3.4 is a negligible small current is passed through a wire of length 15 meter and area of cross section is given. Resistance is 5 ohm. Oh, what is this question here? R is given, A is given, L is given. They are asking to find the resistivity. My God, this is not. It's not coming 10th also. They will not ask in 10th board exam also. You are in 12th, unfortunately. They are giving you to make your moral up. Life is easy. That's all. It is not having any relation with the board examination. I don't know why they give this kind of question itself. Okay, 3.5. Yes, that's the problem. You will not score random. 3.5. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of. Got the answer for 3.5? How much you got? Matching with the book back? So what you took the value of RT? 2.1. No, I'm asking RT what you took? 2.7. R what you took? 2.1. What you took as T naught? 27.5. What you took as T? 100. And you solved and found the value of alpha and you got the value as matching with the answer given. So be very careful. The values are given here. They have told a silver wire has resistance of 2.1 ohm at 27.5. So they are here 27.5 is close to room temperature. That's why it worked for you. If they would have given the value something at 60 degrees Celsius, what you will do? You should not take this as T naught. In this question, why your answer has matched with the book back ideal, the only reason is this 27.5 is almost near to 27. So it will not show in your answer much difference. And alpha is a very small value also. But in the same question, they will say a silver wire has a resistance of 2.1 ohm at 5 degrees Celsius and resistance of 2.7 ohm at 100 degrees Celsius. Determine temperature. And in that case, if you take the value of alpha, that is, take the value of T naught as 27.5, you won't get the answer. Then what you will do? How will you solve the question? Yes, we have to find the value of, you take RT as this value, R as this value, T as 27 and find the value of R for that. And once again, we have to take a new equation where you will have a new value. From both the equations, you will get the answer. I'll give some that kind of question also in the next class. I'll bring new questions where that kind of question comes in the board examination, where you cannot use the value of T naught as the given temperature. You have to make two equations and solve it. Yes. Yes, you can do. That's what we are doing for this question itself. But that formula you can use only if the value of T naught is room temperature nearby. Like here it is 27.5. Are you getting my point what I'm trying to say? Otherwise you cannot. 3.6 have you solved? No. Heating element using nichrome connected to a 230 volt supply draws the initial current of 3.2 ampere which settles after a few seconds to a steady value of 2.8 amperes. So we have the value of currents known here, 3.2 and 2.8. What is the steady temperature of heating element if the room temperature is 27 degrees Celsius? Temperature coefficient is also given. Obviously, that's all. What is this? Simple thing. We know that RT is equal to R naught into 1 plus alpha T minus T naught. Once again, I will repeat this. In all the questions, luckily our T naught value is given as 27, 27.5, so we are able to use it comfortably. Here also it gave as 27 degrees Celsius. So RT can be written as V by IT. Here I can write as V by I naught into 1 plus alpha T minus T naught. V is given. Yes, given. How much is that? 230. It will be cancelled anyhow, so no need of worrying about it. Isn't it? Now IT is given. The initial current of 3.2. So I naught is given as 3.2. IT is given as 2.8. Alpha is given as 1.7 10 minus 27. T naught is given as 27. Cannot you find T? Just solve and get the value of T. So with all the other data given, you can easily solve and find the value of temperature. Is it clear to you? Very basic questions. Today we are limiting ourselves not to go beyond some topics. And even then we have finished almost 1/3 of this chapter. Still many things are there, but we have finished quite a good part of this chapter. Okay. So today what we learned in the class? Today in the class we learned about drift velocity, average relaxation time and the derivation of it, how it came. We came to know that drift velocity is equal to minus E tau by m. We also learned about the relationship of current with drift velocity. I is equal to NEAVD, where small n is the number of electrons per unit volume, E is the basic elementary charge, A is the area of cross section, and VD is the drift velocity. We also learned about what is current density, which is equal to I by A cos theta, from where we understand current is scalar quantity because it is dot product of current density and area vector. I told to you and found the value of resistance and resistivity, the formula of it. Resistivity is m by ne square tau and resistance is ml by ne square tau A. We could realize that what are the factors on which resistance depends, which are length, area of cross section, temperature and nature of material. And in the equation of R, L is there, A is there, tau is there, N is there. We related that. We also found what is the Ohm's law in scalar and the vector form. V is equal to IR and E is equal to J rho, or we can also write J is equal to E sigma. Whatever way you want to write, you can write. With all these things, we also studied about temperature dependence of resistivity, where rho T is equal to rho naught into 1 plus alpha T minus T naught, or RT is equal to R naught into alpha 1 plus alpha T minus T naught. So all these things we learned in today's class. I hope something you have learned today. And the people who have not came for the previous classes, so please make sure that you are with the videos and you are knowing whatever I have taught in up to now in the class. Okay. So we'll meet again. One thing, for the people who want to clear their doubts, I think Anshul already met with me yesterday. You will please share your doubts with me in WhatsApp. Whatever doubt you get in the worksheets that we are sending or any topic, I will make sure that I arrange a class for you separately and I will teach those topics to you. Topics, questions, whatever you may be. Like how I did for Anshul yesterday, same way. Whenever I get time as a group class or as an individual class, I'll keep for you and I'll clear your doubts if you're having anything from your worksheets or from any part of the book or any question. Don't feel any problem. You please share a doubt with me through WhatsApp. I'll be getting back to you for your doubts. Okay? So till then, take care. Bye-bye. You are exhausted.
Sir, we did not get a worksheet and sir.
What, Pratap?
I was not able to get the worksheet yesterday.
Oh, did yesterday worksheet was not there? I'll check. I'll check now. I will check and I'll ask them to upload today itself. Okay?
Okay, sir.
Okay. Okay.